Good evening, everybody. Today, I, Rishav Mandal, and my team members from Team 3 will present the workflow which we have used to predict the sentiments behind the reviews of Uber through Google Reviews platform. My team members list include Mr. Chandrakishore, Harshini, Rohit Sharma, Sharath Kumar, Vani, Vasuki, Muthulakshmi, and myself. Without further ado, we shall proceed. The workflow which we have used to predict the sentiments behind the reviews of Uber through Google Reviews platform. First, we have used the CSV file called Uber Reviews, which we have downloaded from Google Play Store. We have applied CSV Reader. To read the Uber Reviews CSV file. Next, we have applied transformation, in which we applied the node strings to documents to convert the strings in text format. By opening the meta node, as we can see here, we have used the strings to document, which converts the specified strings to documents. Then we have applied column filter. This node allows the columns to be filtered from the input table, while only the remaining columns are passed to the output table. Then we have applied the preprocessing node, in which we have applied punctuation eraser that removes all punctuation characters of terms containing input documents. Then we have applied number filters. It filters all terms containing the input documents that consist of digits. Then we have applied in charge filter. It filters all terms containing the input documents with less than the specified number and characters. Then we have used stop word filter. It filters all terms of the input documents which are contained in the specified stop word list or in the second input table. Then we have applied case converter. It converts all terms in the input documents to lower or uppercase. Here we have applied the uppercase. Then we have applied snowball stemmer. The stems terms contained in the input documents with the snowballs stemming library. Then we have used shuffle. It shuffles all the rows of the input tables which are in random order. Then we have partitioned the data set using the partitioning node, where, as you can see, the first partition contains 350 rows and 3 columns. Second partition contains 150 rows and 3 columns, that is in 70-30 format. Then we have applied the pre-processing node for the first partition. In which we have used the bag of words creator. This node creates a bag of words of a set documents. Then we have used the term to string. This node allows you to convert terms of a defined column into strings and attach a new column to the strings. Like this. Then we have applied group by. It groups the rows of a table by the unique values in the selected group columns. A row is created for each unique set of values of the selected group column. Then we have used a row filter. This node allows for row filtering according to certain criteria. Then we have applied the reference row filter. This node allows rows to be filtered from the first table using the second table as a reference, as you can see. Then we have applied the TF node, the term frequency. It computes the relative term frequency of each term to each document and adds a column containing the TF values, like this. We have applied the preprocessing node for the second partition as well. We have used a bag of words node and the term frequency node. Then we have applied the document vector for the first partition, that is the bigger partition. This node creates a document vector for each document representing in terms of space. Then we have applied document vector applier. This node creates a document vector for each document representing it in terms of space exactly as the normal document vector node. The difference is that this node takes one data table and one document vector in mode as input. Category to class. This node allows you to add a string column to each row containing a document cell, like this. Similarly, we have applied for the second partition as well. Then we have applied color manager to our both the data sets, training as well as test data set. The colors can be assigned accordingly. For the first data set, the negative are marked as red color and the positive are marked as green color. For the second data set as well, the negative are marked as red color and the positive are marked as green color. Then we have applied the decision tree learner. This node induces a classification decision tree in main memory. As you can see, the negative the negative is 163 out of 292. As you can see, the negative is at higher percentage than positive. For words such as nice, for threshold value greater than less than equal to 0.5 percentage, negative is at 60.8%. And for threshold value greater than 0.5, the positive is 92.6%. For words like excellent, the threshold value less than equal to 0.5% is where negative is 64.7%. And for threshold value greater than 0.5%, the positive is at higher side, catering to 100%. For words like bad, threshold value less than equal to 0.5%, the negative is 60.3 percentage, and threshold value greater than 0.5 percentage, the negative is 96.7%. For words like cancel, threshold value less than equal to 0.5 percentage, the negative is 55.9%. For threshold value greater than 0.5%, the negative is 95.8%. For words like ube, threshold value less than equal to 0.5%, the positive is 51.3%, and threshold value greater than 0.5%, negative is 81.4%. For worst or friendliness, we have like this. Similarly, for booked, love, driver, app, awesome, price, option, get, time, support, change, extra. These are the words for which we have predicted the decision tree. Then we have applied the ROC curve. The the X value indicates a false positive rate and the Y value indicates a true positive rate, for which our ASU curve is 0.866. And here, with the help of scorer, which compares two columns by their attribute value pairs, and show the confusion matrix, that is how many rows of which attribute and their classification match. For negative, negative is 48, positive is 16, positive, negative is 14, positive is 55. Thank you. And for the accuracy statistics, accuracy overall is 0.774.